real quick first. So let's go over number 1. Is it what you need to do, Minette? Just hurry and go through homework and then hop on the quiz?
I'm so sorry, guys. I feel horrible. Yeah, is that okay?
Yeah, of course. Yeah. Yep,
Did
we're
you
good
need
with that.
to
So
jump ahead, or are we still okay to go through the sheet?
Oh, yeah. Should we go through I would like to go through the preparation a second and then is that okay?
yeah.
Yeah.
Yep, absolutely. Yep, let's do that. So, okay, so part 2, number 6. What are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? So the first one is a simple random sample was drawn from the population. The second one, the distribution of the sample mean is normally distributed. And the third is the sigma is assumed to be known.
Yeah.
Can we take 7?
Sure. Sure.
What is the point estimate for the population mean? 541.
Very good.
Good.
Okay, and 8, create a 95 confidence interval for the population mean. So I did 541. First, I did minus 1, 0.96 times 32 over the square root of 50. And that gave me 532.13. And then when I did 551 plus 1.96 times 32 over the square root, I got 549.86.
Are we supposed to round that up?
You know, I did round them up, and I have 532 and 550 written underneath it. But when I went back to the answer key, it went back to the original numbers of 532.13 and 549.86.
Because I got 549.87. I just didn't know. I didn't look at the answer key, so I will change that.
Yeah.
Yeah, no, I did 87, and I think that's what the answer key, I'm looking at it now, that's what it says. So,
Yeah.
but I found that often, even with the rounding, like the last number would be different than what I get. So
Yeah.
I'm not sure how that really works, but
Although when we move on to the quiz part, the rounding is never the same anyway. So
yeah,
I
it's
think we're
true.
fine.
And it always says specifically what to do. So I think we're fine on the quizzes. So.
Yeah.
All right. Karina, do you want to take 9?
I absolutely do. So, say the sample size changes to n equals 100. Now compute a 95% confidence interval with the same point estimate. So then we'd have a range of 534.73 and 547.27.
Mm-hmm. Yep. Just using the same formula. So, okay, number 10 then. How does the margin of error for the 90% confidence interval of sample size 50 compare to the margin of error for 95% confidence interval with sample size 100 as the sample size got larger?
I put that the margin, as the sample size increases, the margin of error decreases or gets smaller.
Good.
Yeah.
Is that what I said? Or did I say opposite?
You cut out, so I'm not sure what you said.
Okay, so
I said as the sample size increases, the margin of error gets smaller.
Yes.
Okay.
Yeah.
Yeah, that's what I said. Okay. Good. I wanted to make sure I had that correct. I kept confusing those two because there's one that is just the opposite. So
the confidence of the what is that? The confidence interval. When that increases, then the width of the confidence width, the interval width does increase as well.
Gets smaller.
So
Okay.
Think about it. The more people that, let's say you have a instead of a group of like 50 people that you interview like 1,000 people, and you get their information, then you're less likely to have a larger error because you've interviewed more people, you have more information. So that's why when the sample size gets larger, the margin of error decreases.
That makes
Does that make sense?
Yeah, good explanation. Thank you.
Can we do the next one?
Yep, that's great.
Number 11. We get 90% for the original. So I put 1 plus or minus 1.5 times 32 over the square root of 2. And so my answer is 536.53 and 548.47.
Good.
You know, it's funny. I ran this with two numbers. I ran it with 1.65, and those are the same numbers that Minette just got, and then I ran it with 1.645, and I got the numbers that the answer key said.
You rounded up the 1.64.
Yeah, if you don't round up, you get the answer key number.
Okay, so don't round up then.
Yeah, but then in the homework I use the rounded up numbers and was getting them right. So I don't know.
Yeah, that's what I was confused of the whole time. It seemed like. So anyway, like Karina said, hopefully on the quiz that it specifies, so we don't have that problem. So number 12, who wants to take that?
Well, no, number 12 is just the opposite of what.
That's what we were just talking about before.
Yeah.
So that answers the confidence. As the confidence interval increases, the margin of error increases. Or as it gets smaller, then the confidence interval.
Yeah, I said it the other way, yeah. Same diff.
Oh, I think I did that wrong then.
Oh.
The margin of error decreases with higher confidence of 95%. I'm not right.
I think it's as the margin of error increases or decreases, it has the same effect on the confidence interval. So if the margin of error increases, the confidence interval increases. If the margin of error gets smaller, then the confidence interval also gets smaller. But here it's talking about going from 95 to 90, so it's getting smaller.
Okay, so would that be right? The margin of error decreases with the higher confidence interval of 95%? No.
There's a strange echo when you're talking, Minette. I'm having a hard time understanding.
Okay, you guys are echoing. I don't know what it is. Sorry.
Do Kimmery and Karina, do you guys hear the echo?
A little bit.
Yeah,
what was your question, Minette?
What was that?
What was your question?
So was my answer incorrect then when you said the margin of error decreases with the higher confidence interval of 95%?
So, if you think of the confidence interval is like the stuff that's inside the bell curve, right? Mm-hmm. And so if that's bigger, then there's like a larger spread of all kinds of information. It's all over the place. If that gets smaller, then the margin of error also gets smaller, because then you don't have information that's all over the place. You just have it in this neat little spot. Does that make sense?
Yeah. Okay.
Okay, 13. I actually jumped on with the tutor to make sure I understood this one. Because the answer I got was 1.5, or sorry, 157.35. And when I went back to check,
That's what I got.
Yeah, when I went back to check the answer, it said 158. And no matter how
Did they
much
just
I kept
round
looking
it?
through, yeah, she said that, yeah, but it was it was 0.35, and I'm like, are you supposed to round 0.35?
Yeah, because you don't really, you usually round that to 8. You drop it to 7.
Yeah, that's what I thought. You drop it down to 7. And she
So
said,
what did
no,
she
with
say?
samples, she said, always with sample sizes, you always round up, even if it's one. Well, I'm hearing such an echo, it's driving me crazy. If you,
Me
even
too.
if it's 157.1, hold on, let me see if this works.
You guys hear me better?
Yes.
I'm still
Awesome.
hearing
It's my
echo.
headphones.
I think that might be true, like, theoretically, but that's never been true on our quizzes.
Yeah,
Yeah.
that's the question that I had for her. I said, why is it different now? And she said whenever you're doing a sample size, even if it's 0.1 or 0.01, you will always round up.
When it's asking for a whole
Which
number.
makes sense
Mhm.
if
Yeah,
you're,
when
like,
it's asking
actually
for,
doing
well, no,
stuff
not
in
when
the
it's asking
field.
for a whole number. It's not just for the whole number. She just said with the sample size in general. Whenever you're dealing with the sample size and it's asking you to come up with a new sample size, you'll always round up.
That makes sense in the real world.
Yeah, that's what she said. She said you
Then
can't.
you're not, like,
you couldn't-
discounting the other stuff.
Exactly.
But did she
She
say
said you would
that's
never
how
ask
it
for.
suddenly changed?
It's crazy. She said you'd never ask for 157.35 people because you'd never find a 0.35 person. You always have to round up to find a full person. I'm like, okay, that makes sense.
Maybe just a really
Yeah,
short
that
one.
Yeah, I did have a question by that one because that was the only one that I couldn't get the exact number that the answer key gave me. So,
Yeah.
but I was so close, I knew it had to be something like that. So.
Yeah, I got 157.368 and rounded it up to 158. So I'm trying to figure out how I got that.
Yeah, so 158, I
Piece
guess.
of paper.
Is that what you got?
Yeah, that's what I got too, 157.35.
Fun stuff.
Yeah.
Okay.
Are you ready?
I think
So, do
Yeah.
you feel good to take a quiz?
Sure.
It's still echoing like crazy.
Yeah.
I know. I think it's everybody's too.
Yeah. So we'll do our best to go over.
I'm gonna stick my headphones back in.
Okay.
That'll probably help.
Okay.
Okay. Where'd it go?
Are you ready?
Okay.
Okay.
You want to take the first one?
Sure.
Young adult females. Who is taking a 95 young adult female being considered to be use this information to answer questions 1 through 8. Says exactly mean. One decimal point. So 5.4.
Are you on the quiz?
I was just gonna say, click on the homework one.
Yeah. Is that not which one I'm supposed to click on?
So
No,
it's supposed to be the group meeting one.
I keep doing that. Gosh darn it.
Luckily, we get to take that one twice. It's fine.
Oh, gosh. Right.
I was like, adult female.
I know. It's like, wait a minute.
Yeah, for some reason, I don't know why.
I'm sorry, I had to run for a second because I couldn't hear
You're fine.
you.
You're fine.
You're good. I should
So, you guys, I'm sure, where did you do number 3?
No, I did wrong. Sorry, lady. Okay, group meeting. Yeah. Okay, find the margin of error for 90% confidence interval when the standard deviation is sigma 50 and 5. Round, 3 decimal places. So I'm going to pull up my 90, 0.90, on the z-squared positive side, 1.65, 1.65, and 15. Are you guys done already?
I got 19.6.
Oh, I got 16.5. I put 0.90 after that, yeah? Got the z-square would be 5. Okay.
I'm still getting 19.6 for the margin of error.
So the margin of error is just the z-score times the standard deviation divided by the sample,
This is a sample.
right?
Yeah.
So you guys are on 3, right? Or
Yeah.
Yeah.
Did you, okay. Okay, so the square root of 20 is 5, and then 50 divided by 5 is 10.
Times the 1.5, or 1.65.
And then 5 divided, or 10 divided by 5 is 2, times 1.65. Is that what you guys did?
Oh, I'm sorry. I'm doing 95 instead of 90.
Okay, so I got 16.5.
I'm getting 16.45.
Yeah, and then we round to the 3. Oh, my calculator off. Sorry.
Okay, I'm completely confused what you guys are doing.
Okay, so I typed in the applet point
Right.
to get the z-score of 1.645.
Right. Yeah, I've got that.
The 1.6.
So did you guys not round it up? Did you do 1.645?
That's what I would do.
Okay, because I rounded my calculator rounds automatically, so that's probably why.
Because I was multiplying 1.65.
I say, yeah, and 1.65 gives you 16.5.
Which makes it 16.40. And it says round 3 doesn't. Two.
So would we put 16.450?
That's what I would put.
Okay, tell me how you guys got that. 16450.
Okay, so you type it in the 0.90, and then
Yeah.
you get the 1.15 for the z-score. Right?
1.65, yeah.
Actually, I get 1.645.
Yeah, that's what I got.
Ooh. So you put 0.9 in the applet for the area.
Yes.
And
Mm.
shade
Yeah.
the center.
See, the score that came up for me was 1. What am I doing? 1.26.
Yeah, I got 1.645.
I got 1.26.
Did you shade in the middle?
Shade in the middle, because then it's 1.
At 0.90?
Yeah, shade the middle and then 0.90.
Yeah.
Okay. Let's try this.
The
Thank you. Yes. Okay. I was like, what is going on here? Okay.
So walk me through the rest of this because, okay, so this we have 50 divided by the square root of 25, right?
Right. Yes.
which is 10.
Okay.
So that's going to be 10.
Which is 10,
and then 10
divided by
times-
5.
No, because
No. The whole thing is 10.
5 goes into 50 10 times.
Yeah. The square root of 25 is 5. And then 50
Oh, yeah,
divided by 5 is 10.
And then you
I
multiply
don't know why I was doing
by the 1.645.
that. Okay, that's what I was doing wrong.
Okay. And then I got 16.45.
Yeah.
Yep.
Yeah, that's what I
Okay.
got.
That's what I got.
Doing it correctly, that's what I got. Is that what you guys all got?
Yep.
So it's not the 19, right?
What's the 19? No, it's not the 19. I looked over and I was using the 95
Oh,
score, which is 1.96.
okay.
And that gives us the 19.6, but we're looking for 90, not 95.
Perfect.
So you guys got 16.45?
Yes.
Yes.
And are we adding a 0?
So this round to the 3 decimal places, there's not a 3 decimal place.
Yeah.
Yeah, I just put in the 0.
Yeah.
Oh, behind 5?
Yeah. So then it'd
Okay.
be 0.450.
Okay.
And do you want me to do the next one?
Yes.
Yes.
Okay, I'm not exactly sure, but I was thinking of that. So I went back over to the reading, and it has a chart of points.
Yeah.
It says for which of the following statements I'm putting X bar is of mu.
Yes.
Is that what you got?
Yep.
Yes.
Okay, I didn't hear anything you guys said.
Sorry, C.
X bar is the point estimator for mu.
For mean. Okay. Okay. Yeah, that's what I had.
Okay, so number 5 is Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample size of n equals 64 and computes X bar equals 526. We need this information for 5 through 8. Okay, so we're looking for the lower limit.
So what'd you guys get for that?
I'm still working, sorry.
Okay, that's fine.
Oh,
So remember, you're looking for the lower limit.
Okay, I got 498.315.
0.315?
Yeah.
Yes.
498.315.
Yep. Yep.
Cool.
And then the next one is just the upper limit.
And I got
Just do it the other
And
way.
I got
what did you get on the last one?
5.685.
Yeah, we're supposed to round. So 690? 553.685 and then we round.
Sorry, what did you guys get for 5?
498.315.
Yes.
Huh.
Is that what you got, Ruth?
No, my numbers are screwy, so I'm kind of like, wait, that doesn't seem right. Something I'm not doing correctly.
Okay, let's walk through
So what
it. So the square root of 64 is 8. Divided by 113 equals 14.125
Mm-hmm.
times 1.960, which equals 27.685.
Yep, I see what I did.
And then you take that from 526.
Yep.
Okay, yep. Okay.
So for the next one, number 6, I got 553.685.
And how are we supposed to round?
Wait, say that one again?
553.685.
Yep, that's what I got.
That's what I got too.
Okay.
Is that what
Help
you
me
got,
out
Karina?
here.
Is that what you got, Karina?
It's not. Help me out here. What occurred?
Okay, so we're still, all we're doing is still adding the 27.685
Yes.
to 526.
Oh my goodness, I see.
Yeah.
Okay, I got ahead of myself. I got it. I got this.
So
I
the
can
thing
do
that
math.
says round to the 3 decimal places, that's not saying a whole number. That's just saying the 3 spaces behind the decimal. So I think we would just leave that 685.
Perfect.
Yeah.
Yeah.
I wouldn't change that at all.
Okay. So what would happen to the width of the confidence interval if you increased sample size? So if the sample size was increased, then the width would decrease, right?
Yes.
Okay. I'm thinking of Karina's explanation in my head. So then the next one, what would happen to the width of the confidence interval if Gina changed it to 99 confidence interval? Now that would increase, right?
Yes.
Okay, I'm still confused about that one.
I think Karina, you explained it really well the last time.
So, let me pull this back up.
So here's the notes that I put. Increasing the confidence level will lead to larger values
Okay, when I typed it
of the z-score. So if the z-score is increased, then the margin of error would also increase. This would lead to a wider confidence interval.
perfect.
Yeah.
So the only time that it decreases is if your sample size increases because you have more information to work with.
Yes.
Perfect.
Okay, so Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours, and they want a 95 confidence interval with a margin of error of 50 hours. What sample size do they need? Woo, we got to work it backwards.
So then it would be
So 1.96 times margin of error is 50.
Wait, 95, yep.
yeah.
Divided by 113 over, no wait, sorry, 400.
Oh, I was like, where did you get 113?
Yeah,
Now I'm really
I was looking at the one on top, sorry. And then the margin of error is 50. And then we'll square it.
so. What are we multiplying? Let me think. We're multiplying 1.96 by.
I didn't catch that. What was
So
that?
lay it out. 50 equals 1.96 times what?
50 equals what?
Oh, is that not how we lay this out? Let's see. Never mind.
Let me see.
I'm doing something wrong.
You do Z times the standard deviation divided by the margin of error, and then you'll square it.
1.96 times 50 divided by 40 squared.
Yeah, so it'd be 1.96 times 400
Oh.
Hmm.
Divided by
divided by 50.
Okay, I've got this swapped.
So what did you guys get for that?
I got 245.8624.
That's what I got.
And so then we'll round it up to the nearest number, which is 246.
Yeah.
Yep.
And you're right, on this one, it even says it in the parentheses to do it the way that your tutor said.
Yeah.
Okay, so did you get 245.864?
Yes.
Okay, and we're going to get 236, right?
Yep. Okay, so the mean salary of actuaries is Q equals 100,000 and standard deviation is 36,730. You are interested to know if the mean salary for the women actuaries is different from the population mean, but are not sure if it's higher or lower. You set up a hypothesis test and level of significance, which A equals 0.05. Now I have to remember this from last time.
I know.
Okay. So let's see. You collect a random sample of N equals 36 women's salaries and find the X there, even 11. Use the information for your questions 10 through 12.
Okay, so
So what is the lower limit of the 95 percentile confidence interval? So if we're at 95 percentile, the z-score is 1.96.
1 point what? 1 point what?
96.
Oh, perfect. Okay.
And the standard deviation. Oh, wait. Okay, it's 36,730. Divided by sample mean. 36.
What's the vote? I got 99005333.
Okay.
So I got 99,001. Or 2, I guess, if we're rounding to a whole number.
Boy, I'm off.
Whoa, you got what?
Okay, so we're looking for the low limit of the 95 percentile confidence interval. I got 99,001.5334. Did anyone else get that?
I got 99,001.533 on threes.
Okay. So I've got 99,000 and 1.533.
What did you get?
99,000 and 1.533.
Yeah, so we rounded up to 99,002.
Yeah, so it would be 99,002.
Okay. Did you get that, Chris?
I must. What did I do?
What did you guys get?
The Z was 1.96, right? The standard deviation is 36,730.
Right.
And then divided by the square root of 36.
Right.
Okay. And I got 6121.666, a bunch of sixes.
Yes.
Right?
And then multiply that by 196.
Okay. Sounds good. I'll reach out to that.
So then that's 1 point,
I'm looking at it.
or 1199.8
Okay. Thanks so much.
something.
Yeah, 0.4666.
Okay. Okay.
And then we subtract that by 111,000.
Okay. I see what I gotcha.
Is that what you got, Ruth?
That's what I 99,002.
Yes.
99,000. Are there 2 zeros in there? 99,002.
Yeah,
Yes.
99,002.
Okay.
99,002.
Yeah. Yes. Okay.
For number,
We're good.
Can I do number 11?
Yeah.
What is the upper limit of this 95% confidence interval? Round to the nearest whole number. And I got 122,998, and that is rounded up.
So is that what everyone else got?
I got
No,
122.
999.
That's what I got.
What did you get? What did you get?
122,999.
Yes, that's what I got.
Oh,
Okay.
you did?
So it was like what the parentheses said earlier to do. You always round up.
Yeah. So I was rounding to the nearest whole number, and so in my whole number I got 122,998.46667.
Yes. So then it would round up to 999, because you always round up because you can't have 0.46 of a person.
Yeah.
Oh, I see. So
Yeah.
Because, yeah, it wants a whole number.
As fun as that would be.
okay.
Okay, so 122,999.
Perfect.
Yes. Oh, there's only one more.
No, it's okay.
Hold on.
Okay,
Hold
there
a
are
second.
3
What
requirements
was the last one?
when computing a confidence interval for the mean. They are: a simple random sample was drawn from the population. That's correct. The X bar is normally distributed. Correct. So it's all the above.
Yeah. Yeah. because we have to have all of those.
Yeah.
Can
Oh, that was.
we go back to 11?
Yeah.
Yes.
Yeah.
On the upper limit, we won't round up on that.
Yeah.
We'll round down. Because it's not we're not looking for a sample number.
Ooh.
So it would
So
be
it would
8.
be 9/8.
Good catch.
So we
Rick.
only round up when it's a sample.
Yes.
That makes way more sense.
I was like, wait a minute. So yeah.
Okay, so why don't we go over all the answers real quick to make sure we all got the same?
Okay.
Okay.
So 3 is 16.450.
Yes.
4 is C, or X bar is a point estimator of U.
Yes.
Yes.
Number 5, 498.315.
Yes.
6, 553.685.
Yes.
7 is decrease.
Yes.
8 is increase.
Yes.
9 is 2, 4.
Oh, whoa, what?
246?
Yep.
246. Okay, got it.
Yes.
Okay, so 9, 2, 4, 6.
Okay.
Yes.
Okay. 10
So then would it be
is
similar on this
99.
one?
On this one, it is because it's 99,001.533. You would round up to
Yeah.
99002.
Okay. Okay.
So 99002.
Yes.
And 11 is 122998.
Yes.
And 12 is all the above.
Yeah.
You ready?
Okay.
We ready
Does
for this?
everyone feel good to get it?
I feel good. I feel awesome.
Go.
Okay. Awesome.
That's the best feeling in the world.
Rock.
Awesome.
Thanks, Rob.
Yay!
Thank you.
Thank you, ladies.
Try to rush off. Thank you, guys.
As always, wonderful.
Bye.
Bye.
See you on Thursday.
Good job. See you in a minute.
Bye.
Bye, ladies.
Awesome.
Bye, ladies.